video, we are going to look at some theories or laws under operation of sets. So the first law we are going to look at is the De Morgan's law. De Morgan's law. For any set A1, A2, A3 to AN, we have that first thing we need to know that A1 union A2 union A3 union AN complement is equal to A1 complement intersection A2 complement intersection A3 complement dot intersection AN complement. And the second one is if we have A1 intersection A2 intersection A3 intersection AN complement is also equal to A1 complement union A2 complement union A3 complement union AN. So for this is the De Morgan's law. The second law we are going to talk about is the distributive law. The distributive law. And for any set A, B, and C, we have that A intersection B union C is equal to A intersection B union A intersection C. And for A union bracket open B intersection C, we have that A union B intersection A C. So for this is the distributive law. Let's take an example. So for this example, if the universal set is given by X is equal to 1, 2, 3, 4, 5, 6, and A is given by 1, 2, B is given by 2, 4, 5, and C is also given by 1, 5, 6. Are three sets. We should find the following. A, they're asking us to find A union B. So for A union B, we could know that this is our A and this is our B. Union means you are just adding them together. So 1, 2, 4, 5. So it will be 1, 2, 5. Question number 2, we are supposed to find A intersection B. And for A intersection B, we know that it's 2, right? 2. Let's go to the third question. We are asked to find A complement. And for A complement, we are going to look at the universal set and check the elements which are in the universal set and they are not in set A. And we know that to be 3, 4, 5, 6. So A complement consists of elements that are in the X, which is the universal set, but not in A. Let's move on to our D. For D, we are supposed to find B complement. In that case, our B complement will be 1, 3, and 6. Let's look at E. For E, you're supposed to find A. So for E, we are going to use De Morgan's law by finding bracket open A union B complement and A complement intersection B complement. So in this case, we are going to use De Morgan's law. So for De Morgan's law, we'll have that we need to find our A union B complement. And A union B complement will be, we have to find A union B complement. So A union B complement. When you have A union B, let's put A union B. And for A union B, we're going to have 1, 2, 4, and 5. And we are finding the complement. And in that case, we're going to have our answer to be 3, 6. So using the De Morgan's law, finding A union B or complement, we're going to have 3 and 6, which is the same as A complement intersection B complement. And in that case, A complement is this 3, 4, 5, 6. In intersection B complement, we have 1, 3, 6. And in the intersection, we have it to be what? For the intersection, we have it A intersection B. This one, we have it to be 3 is 3, right? Yeah. And their intersection. So we have our A, which is this, and B intersection. So the answer will be 3, 6. Very simple as that, because we have this here, we have this one here. So our A complement intersection B complement to be. Let's look at F. For question number F, we are supposed to use the distributive law by finding. So F, using the distributive law by finding A union bracket open B, A intersection bracket open B union C, and bracket open A intersection B union A intersection C. With that, we have that our A, we try to break it down. So our A will be, they give our A to be 1 and 2, then intersecting with bracket open B union C is going to give us 1, 2, 5, and 6. So in that case, B having this union, intersecting with it, we know that our answer will be 1 and 2. 1 and very simple as that, because we just break it down. Our A, this represents our A, and this is our B union C. Then we find the intersection, which is the same as this. So when you express, you're going to have the same. Let's do it. For our A intersection B, we know that our A intersection B was 2. Then the union of A intersection C is 1. So you finding the union. The intersection of yes, you finding A intersection C is 1. So you finding the union, you're going to have 1 and 2. And in that case, the same as that. So we're trying to prove that the laws are the same. Let's look at something called the Cartesian product. Cartesian product is also another law, Cartesian product. And a Cartesian product of two sets A and B, written as A times B, is the set containing ordered pair from A and, that is, if C is equal to A times B, then each element of C is of the form X and Y, where X belongs to A and Y belongs to B. So in that case, if C is written in the form A times B, That means that S comma Y, where our S belongs to A and our Y belongs to B. So in that case, when you write A times B, we have it to be the way that X and Y, that is X an element of A and Y is. Let's take a look. So let's take example. For example, we have our A. If A, that A is equal to 1, 2, and B is equal to H and T, we should find A times B. So for A times B, we'll have our first to be 1 and H, comma. We have 1 and T, comma. We have 2 and H, comma. We have 2 and T, comma, and we do the same thing for that will be 3 and H, comma, and 3 and. This is the Cartesian product.